Hello everyone. In the next few minutes, I'm going to present our paper entitled Holistic Interaction Transformer Network for Action Detection. First of all, what is action detection? Since here we are doing person-based action detection, we need to first locate the persons in the frame. Then we can try to answer what they are doing. How do we figure out what they are doing? We usually look at the surrounding context, such as other persons, objects, the person's hands, and also their pose. Previous works have attempted to reframe action as interaction. AIA, for instance, compute two kinds of interaction: person-person interaction and person-object interaction. And they do so using objects that have high confidence score. But as you can see here, high confidence score does not mean useful. ACAR, on the other hand, compute person interaction with the whole context. But these methods, they fail with challenging actions, especially those that have clear pose signature and those that are unrelated. Here is the intuition for our framework. We also reframe action as interaction and learn person-object interaction. However, we select only useful objects by using both IOU and confidence score as selection criteria. And we also try to capture more atomic actions by looking at the person's hands and also at their pose. Now I will give you an overview of our approach. Given a video frame, we compute person, object, and hands bounding box proposals, as well as the person's poses. After passing the video through a video backbone, we use ROI line to extract person, objects, and hands features. Then, using these features, we compute different kinds of interactions, namely person interaction, object interaction, and hands interaction. We use cross attention to model each of these interactions. Then, to help the modality learn dense and filtered features, we introduce the intra-modality aggregator for the RGB modality called ZR, which outputs a learned combination of features from every interaction unit. The pose modality is similar to the RGB modality, only that we are learning pose features. We use the outputs of the RGB modality as helpers. We use a lightweight transformer encoder to extract pose features. Then we compute pose person, pose objects, and pose hand interaction. ZP is the intramodality aggregator for the pose modality, and it is similar to ZR. We subsequently combine the features from the pose and the RGB modality using our proposed attentive fusion module. This module concatenates then enhances its inputs via self-attention. Then to learn actions with long-term dependencies, we use a temporal interaction module that looks at features from past and future frames. Finally, our classifier consists of two fully connected layers. We train and test our models on 4 different datasets and outperform the state-of-the-art on 3 of them. Our method also won second place at this year's ECCV Deep Action Challenge Track 2. We qualitatively compare our framework with AIA, which learns person-person and person-object interaction. This is to further validate our use of more atomic features. The classes in the top row are all hand-related, and AIA fails to correctly classify them. However, our model easily spots these actions. We observe the same pattern for the classes in the bottom row, which are pose-related. Such an outcome outscores the importance of these atomic instances, and also the effectiveness of our interaction modeling method. Thank you for listening to our presentation. Please scan the QR code to access the source code of our framework.